Hi folks, I'm Dave. I do security for a living across EMEA along with compliance. And while I have an EMEA remit, in practice this means I tend to spend most of my life in London, whether that's either in Docklands or in the Square Mile. So this is actually my first time in Israel and I'm loving it. So really pleased to be here and looking forward to be back at some point in the future. So we're going to have a bit of a canter through the shared responsibility model and concentrate more on what we can do with multi-account architectures. The reason why we're going to be taking the shared responsibility model fairly quickly is we've recently managed to be able to post a rather more detailed video of me doing a session on the shared responsibility model up on YouTube, and there's a link to that partway through this presentation. So with the shared responsibility model, which I am assuming that you've all heard of, the question comes as to who actually manages what. I am hoping that this picture is familiar to everyone in the room from our documentation. Raise your hand if you know it well. A few. Not half, which is a bit interesting. So essentially, what this comes down to, this is a standard picture from our documentation, and it shows a horizontal line of demarcation of responsibility between you guys and us at AWS. So we look after all the orange stuff below the line, which is all the stuff that we assume you guys don't want to look after in terms of environments up to and including hypervisors, storage from the point of view of RAID and presentation over iSCSI, database primarily from the point of view of what we do with account data and IAM data, and networking to present you with a sea of layer 2 in an availability zone, and layer 3 routing and security groups and network access control lists, plus of course internet gateways and virtual gateways on the network side. Above all that, the idea is that you're responsible for all that. This picture is a little bit simpler than it actually turns out to be. So in terms of managing your AWS environment, you really interact with it in two ways. To manage your actual instances, you've got SSH for Unix systems, RDP for other things. Be sure that when you run RDP, by the way, over the internet, you only ever fully encapsulate it in a VPN. Database, of course, you've got your usual PL/SQLs of various varieties, and file transfer is just regular SFTP or other means to your instances as you choose to serve them. So does one model work for all our services? And the answer is not really anymore. So when we introduced the previous diagram, AWS was a rather simpler beast. It's grown a lot since, and we now have 50+ services to our name. So really, we split things out into 3 different kinds of service. We mark these as infrastructure, container, and abstract, which is a bit different from what NIST do with their infrastructure, platform, and software as a service. There is a reasonable mapping to be made between them, but they're not actually identical. So infrastructure services actually works out as being exactly the diagram that you saw before, but with identity and access management tacked on the side. The thing about the line of demarcation for shared responsibility is it's also a line of demarcation for visibility. So our view is that that which you can't see, that which you can't affect, is there really a particular reason why you need to see it? We probably don't think so. So in terms of what goes on underneath the hypervisor and our maintenance of it and so forth, that's something that we don't think should trouble you. We just look after it and present you with something consistent and reliable. Above that line, essentially, it's an operating system and you're a root on it. You deal with it using all the tools that you know and are familiar with. From a firewall perspective, we give you security groups, so you wind up actually being able to have a stateful layer 3 stateful inspection firewall attached to every single one of your network interfaces, and you just deal with all the environment on top as you see fit. So you go managing your instance using the APIs and SSH and so forth that you're all familiar with. and you use AWS API calls using our signature v4 algorithm into our API endpoints to manage the standing up, shutting down, and general provisioning and configuration management of the immediate environment that supports your instances. I'm talking about instances here. We do have a number of infrastructure services, not just EC2, but EC2 is probably the poster child for this. So shared responsibility works out that we just look after the underlying stuff, and you look after everything at operating system level and above. That includes high availability, which can get a bit entertaining, bearing in mind that the AWS network doesn't actually support multicast, but most of the vendors of highly available solutions have tweaked things in order to actually give their capabilities native high availability monitoring using other standard protocols, just directed TCP and so forth. You're also responsible for backing up and managing your own data and backups, and obviously using IAM to carefully grant permissions to appropriate individuals and groups in order to get only people who need the ability to manage your environment. If we go one stage out to container services, you'll see the demarcation line has moved upwards. So in this case, we actually manage the operating system for you. So we look after OS patching, we look after OS backups, we look after the actual application platform that sits on top of the operating system as well. So in this context, well, you still get firewall rule configuration, but you just wind up looking after your data, its configuration within the actual application environment, and dominion over who gets access to it. Again, you wind up using AWS, you wind up using your own management capabilities to talk to the applications, and you wind up using AWS API calls to actually stand up the services, manage and maintain them. Poster child for this is our RDS relational database service. And if there's any Oracle DBAs in the audience, I like to characterize where the line of demarcation is actually in Oracle terms, because it just seems to be the most concise way to me. You get DBA, we get Cis DBA. So you can actually do a lot of Cis DBA functions in a shared responsibility, in a container service. But you wind up doing this via options and preferences files. Also, you don't get to tune storage as such because we just expect you to go doing provisioned IOPS into your database instances. Moving on to abstract services, this is where the line moves even further up, and you just wind up having control over your data, its encryption, and by identity and access management, who gets access to it. And the poster child for this is S3, our object storage capability. Now, where you should potentially choose to use one of these or another, because the line of demarcation is both shared responsibility and shared visibility, there's swings and roundabouts on it. So if we look at the comparison between infrastructure, container, and abstract services regarding what you both have access to and control of, if, for example, you have a particular compliance requirement that needs you to be able to get access to the underlying Unix logs, for example, of the Linux instance that's propping up your Oracle database, then because in a container service you can't actually get access to that information, RDS, if you have such a requirement, may not be for you, and you may need to actually back off to EC2 and then stand up your own infrastructure on top, your own database engine. This also has implications when it comes to the scope of our external certification audits, which I'll be coming on to a little bit in a moment, about how you have different services either in scope or out of scope of different audit standards. So for example, ECS, our container service, right now isn't in scope for PCI DSS. So this means that you cannot stand things up in ECS and push CVV and PAN through them. However, this does not stop you actually backing off to EC2, standing up your own Docker environment, and then satisfying your auditors that you have built and are operating your Docker environment appropriately. So, as I said earlier, we do all the dull stuff so that you don't have to. And it's actually rather easier to look at satisfying your auditors of your security in an AWS environment than it would be if you had to do this on-premise, because there's literally less work for you to do. Also, of course, you have the means of doing continuous monitoring. One thing about interacting with an environment purely through an API is that API becomes a single point of visibility and auditability and control. You can get much better view of what's going on in your environment in a cloud context. Also, of course, under the lid, if you were to look at our external certifications, of which these are a small subset, so the ISOs, ISO 27001, 27017, 27018, and 9001 aren't listed here, but we actually have a master control set of about 1,800 controls. When we need to, by customer demand, to meet an external audit requirement, we just make a mapping between our master control set, the controls required in the audit standard, and then we get the auditors in. So, because we have customers who have very high demands when it comes to security, everyone gets to benefit from this stuff. However, if you do need to meet compliance requirements yourselves, you still have some work to do. So we have these certifications on our services below the shared responsibility DMARC, but when you go building environments on top of us, you still need to satisfy your auditors that you're building and operating them correctly. So in an ideal world, you would get hold of our audit reports for our SOC 1, SOC 2, and PCI DSS reports, which are available to all our customers under NDA and on request. You would get your auditor, so in the case of PCI, your QSA, in. You would satisfy them that you have built and are operating your environment on top of us appropriately, and you would then put a copy of our audit report, which we get done by Coalfire in the case of PCI, and Ernst & Young in the case of many of the other ones, including our ISOs, in front of them. And then an enlightened and pragmatic auditor would take what they'd already measured of your environment, take our audit report, stitch the two together, and essentially say, right, I'm happy with the full stack here, I'm going to sign this thing off. Now, we appreciate, in fact, we take a very Unix view of the world in that we trust you guys to know your businesses better than we do. So we give you the opportunity to do all sorts of cunning stuff, but this also gives you the opportunity to make mistakes. So we want to help you guys minimize the propensity for these things to happen. So we've been working with a bunch of external bodies to produce some reference guidelines. I'm a particular fan of CIS benchmarks. I've been using the Linux and Apache ones for years. Hands up everyone who also knows and loves them. We've got a few. Well, I do seriously recommend them, not just in the context of AWS, but in the context of operating system hardening and also hardening of specific applications as well. So we've put this foundations benchmark together, which operates in the same way as all CIS benchmarks do. It comes in the form of a set of recommendations, and for each recommendation we have a description, a rationale behind why it's there and the way it is, a scriptable test to determine whether the recommendation has been made and is in place and is active in your environment, and a remediation mechanism to put it in place if it isn't. Now, when doing CIS benchmarks normally for operating systems, sometimes there are things I can't follow because following the recommendation would cause the software I needed to use to stop working. You've got to be a bit pragmatic with these sometimes, but with the CIS benchmark for AWS Foundations, I really do say pick it up and just follow the thing. I recommend everything it says. The one thing I will say about it is it does not say turn on detailed billing. I think that may be something for 1.1, but it's a 1.0, and it's a 1.0, it's great. We've also recently, this year certainly, gone and released some assets under our Enterprise Accelerator program, which used to be called, internally codenamed Gold-Base. That name may have escaped into the world. You may still see it around, but marketing went and renamed it. So we've gone and produced a set of assets to enable you to put environments together that we think, if you are careful about how you configure and manage them on top of these recommendations, will enable you to meet requirements of NIST 853 or PCI DSS. So these come in the form of a bunch of architectural diagrams, mappings of controls between controls in the standard and things that can be implemented in AWS, and also CloudFormation templates, and a CloudFormation framework. So I think of CloudFormation as being very much like Linux Kickstart, but at cloud scale. So you write yourself a big bunch of code to do neat things, and you go and use it. As things follow over time, you modify this stuff, potentially different people wind up modifying it. It can be very easy, having been there and done it, to write yourself a great tower of elegant code that is nonetheless unmaintainable. So what we've actually done is we've put together a modular framework for CloudFormation templates to actually make it easier to have a consistent framework, not only in yourselves, but across multiple AWS customers and organizations. So anyone who winds up doing consultancy for multiple customers will hopefully have fewer surprises when they see different customers' CloudFormation frameworks. Back when I was at Sun Microsystems, we did something very much like this for Jumpstart, which was the Solaris equivalent of Kickstart, called the Jumpstart Enterprise Toolkit. And it really drove Jumpstart adoption, Jumpstart consistency, and made things a whole lot easier for everyone. It was very popular. And I sincerely hope that the Enterprise Accelerator causes history to repeat for CloudFormation templates. And when it comes to security training, we've got a couple of new courses that have come along. There isn't a security-specific exam yet, although there are always security elements in our exams. But seasoned AWS watchers will know that where a 3-day course comes along, an exam normally isn't that far behind. In terms of resources, you don't need to go making notes on all this, and the slides will be made available after the session. These are a bunch of useful links, including to some of the resources that I was talking about earlier. And as I mentioned right at the start, we've managed to get some videos up on YouTube of a much longer and more detailed version of this shared responsibility session, along with some further sessions from the security roadshow that we ran around the UK earlier this year. The one session that we haven't actually got online yet is what I'm going to be talking about right now, which is how to go about doing multi-account architectures to get both mandatory access control-like features and also reduce risk around the root user in AWS. So mandatory access control, as epitomized in SE Linux, or for old fogies like me in things like Trusted Solaris going back 20-odd years, hands up if you're familiar with it. Just a couple, but a couple. This is not bad. So how to tell whether you're in a mandatory access control environment? Root is not all powerful. AWS is not a mandatory access control environment currently, although we do now actually have one mandatory access control function, and that's Glacier Vault Lock, so that customers can take normally things like their business transaction records, and they can put them in a vault-locked vault such that the policy on that can be made immutable even to the root user in an account, and thereby it's been determined by Cohasset associates who've been doing SEC audits for about 40 years that this can meet SEC and FINRA books and records handling requirements. Now, how can we make more services behave like this? If you start looking into cross-account access, you can get pretty close. But first, just a brief diversion. S3 is supposed to stand for Simple Storage Service, and indeed does. I like to think of it as S4 these days, because it's actually got some, it's actually, with all the security extensions on it that it's accrued over the last 10 years of its life, it's more of a subtle and sophisticated storage service. But onto things it can do. Again, looking around the room, I see there's a number of fellow geeks of a certain age in here. Who here will admit to, in their youth or university days or whatever, banging on a VAX? We got some old VAX hackers in the room. This is great. VMS was the first thing I came across that actually had a decent versioned file system. And you found this out, you looked at your files, and you put some extra switches on LS, and you found out that all your files had a version number on the end. So it was file name, semicolon, version number. And so when you actually wrote a file, when you first created a file, you saved it. If you then edited it, saved it again, it wouldn't overwrite the first one. You would wind up getting file name semicolon 2 as the next version. You then also had the purge command, which would delete all the old versions of your files and just leave you with the current one. S3 is actually not that much different, and I like to think that probably some of the S3 engineers are old VAX hackers themselves, but what you wind up having is you actually get, rather than semicolon version number as a hidden field, you get file name, great big machine-generated hex string. And again, you can expose these using switches on LS if you want to. But what this means is if you put that together with the ability to use rummages for house keys, a multi-factor authentication token using RFC 6238 time-based one-time passwords like this Gamelto thing here, you can actually take away the ability to run the purge command. So all of a sudden, you've got something that starts looking like an append-only file system. This is good for evidential integrity when you start thinking about it. Now also, so you want to potentially go taking all your logs that you generate when you've got appropriate logging capabilities turned on in your AWS account, which we hope you all do and which the Cis Benchmarks says you should have. How about actually making the log repository that you've got essentially write-only? There's other ways of doing this. We've all done the old trick whereby if we've got some files on a Unix box and we want to make them immutable even to the root user on that box, we would stand up a second box alongside, have the files on there, NFS share them read-only with the box that we want to mount them up on and have them immutable on, mount them up, even root can't go tampering with the files. You can do something very similar with S3, only instead of actually mounting your repository read-only and full of data, you mount your file store cross-account instead of cross-system, and you mount it write-only. So all of a sudden, you have a bucket that has a policy on it that says this account over here on the right can write objects to it, but can't list objects, can't get objects, can't get the bucket policy. So there's this black hole that you fire logs into, and once they're past the event horizon being the boundary of your account, you have absolutely no dominion over them, even as the root user. Now, having spent more of my life doing trusted Solaris than I care to think, I call that mandatory access control. And it's a fairly common thing to do. Now, I am running short of time here, so I'm going to skip over how you actually set this up, although this obviously will get in the slides as you will see them. So Also, it's worth noting that detailed billing is a good source of log information that kind of hides in plain sight. I mean, we all want to get paid, so anything that actually generates a cost, generates a record in the billing system, and if you're taking detailed billing, that just comes out every few hours as a CSV file, which you can load into and analyze in anything. So if you put this all together, you get something very interesting. Let's just briefly skirt over what goes on in a standard AWS account as we'd like to have it. This is mostly covered in the CIS benchmark anyway. So have a root account, which you shouldn't be using. So lock the MFA token on it on the in the safe. And because root shouldn't be used, be sure to raise an alert when root ever gets logged into. Now, in terms of how you structure the ability to manage IAM, a friend of mine who actually put this together, and I agree, that it's good to have two separate accounts. We call them master and manager. The top one can generate policy but not assign it in terms of roles and permissions. The bottom one can assign policy but not generate it. So by having this, you immediately have a two-person rule whereby two people would need to collaborate in order to do something mischievous, rather than having one user who had dominion over IAM, at which point they could fairly easily rewrite themselves a role equivalent to root. So if you do this in every account and zoom out, you get something interesting. So how about having an account that just does billing? And it has a bucket in it, shared write only, as previously described, with all the other accounts, that just handles your billing data. Do the same thing for your log data. And for both these accounts, the only time they ever need to be logged into is when you need to change the bucket policy to go share those buckets with a new account that you may have created. Obviously, you set the logging from your billing account to point to your logging account, and you set the billing from your logging account to point to your billing account. Some people like to have a dedicated account for IAM users. Another thing about this is that if you set up federation, it means that you can, because you can federate from multiple AWS accounts back to a single IDP your side, you're able to keep your accounts and users and permissions straight. So in the case of movers, leavers, joiners, someone leaves, you get rid of their account, you get rid of their login credentials in your federated primary IDP. They're gone from all your AWS accounts. We like to have just one permission per IAM user, and that's the ability to assume a role. So this is literally the IAM policy for the users who have privilege to actually use the CLI or the SDKs or the console. Obviously, you set your billing and your logging up. Your resource accounts, with billing and logging set up appropriately, are where you actually have your resources and where stuff happens. Your admin users wind up using cross-account STS credentials in order to assume roles in your resource accounts and do useful stuff. Obviously, you're going to have multiple ones of these accounts. You definitely want to have separation between your dev test and production accounts, because any programming errors that may result in repeated calls to API endpoints could result in us throttling the ability for an account to call that API endpoint to protect our own environment. And you wouldn't want a simple development bug like that to have adverse implications for the responsiveness of the API in a production environment. These obviously have their billing and logging set up accordingly. Some people like to have a separate backup account. Others don't. Bucket policy on this would be rather different in that accounts need to be able to read and write their own backups. And also having a separate audit account that has read access to everything is a good idea. So this is where you would run your security incident and event management and monitoring system. You could also, this picture isn't necessarily complete, complicated though it is, in that you could actually have more than one audit account. This is intended primarily for your internal auditors, but you could have an account just like it for your external audit team, so that to minimize the disruption of what happens when your auditors come in every 6 months or every year or whatever. And to be a bit more mischievous, what I'll leave hanging in midair is you could even have a separate audit account for your regulator. I know some people are thinking about that. I am going to skip over all this because it's covered in the CIS benchmark in reasonable detail. This obviously is what the picture looks like for actually generating and analyzing and reporting on logs with flow left to right. CloudTrail currently takes anything between 5 and 15 minutes to generate a log record from an event, but all the others are the matter of a number of seconds, maybe a minute. So with CloudTrail as an exception, and we are working on speeding it up, you're looking at maybe a minute to go from log record generation to alert of anything interesting as a result of that log record being disclosed to you on the far side. And at this point, I'm going to hand over to my co-presenter to talk about what's going on at TradeAir.
My name is Tamir. I'm from TradeAir. TradeAir is... oh, great. Did you copy the right slide?
I think so, sorry.
Okay. So, as you see, overview about TradeAir to be discussed. Great. Okay. So TradeAir, we are an FX company. We are in the FX market for the last 5.5 years. We are a worldwide company operating in Singapore, EMEA, and the US. We have over 50 customers, which are banking, UBS, BNP, broker, probably names that you are not familiar with because probably you're not from the industry. We have an R&D team in Israel of 50 people and offices around the world. Just to give you a quick background about
חצי יוזרים שמשתמשים באפליקציה ובשירות שלנו. באירופה.
Okay, just to give you a quick background about our product before we sit on the network and speak about security. So we have an HTML5 application, which is a web application, speaking with an API interface called TradeAir API using a JSON API with our core engine. Our product is a rate engine. Rate engine is an application which allows local banks to create their own prices and stream it to other people who are interested to trade with. So, for example, if you are a customer in Bloomberg, you can get prices for Bank Leumi, which are created from our rate engine, who create the prices for you. We have additional components which I don't think that are really interesting for this discussion, and we have a lot of integration to other banks worldwide who provide us market data, and other integration into bank back offices and other operations. So, low latency, high performance. I'm not sure if any of you is into the fintech, but the main issue about fintech is volatility and the amount of market data that you can receive, and the amount of market data that you can receive in a second and spike in the market. So this is a general product diagram of the application. Now, this is not the right slide. Anyway, so if we speak about security, so TradeAir security is no different than any other company. We have internal security and external security, and we invested a lot of time and effort to shape our security on top of Amazon services. You have to remember that providing a service to banking on Amazon Cloud is a challenge because banking historically doesn't want to have their service outside of the banking. They like on-premises services and they don't like SaaS services. So we invested a lot of time and effort in order to construct what you see here as a diagram. From security need, obviously we have external security need. We provide a service. We don't want to be attacked. We don't want to have DDoS. We don't want people to abuse our services. So actually in the first 3 years of the company, we invested a lot in external security. All the HTTPS, all the interesting stuff. But the reason that I'm talking now today is because of the internal security. So as a growing company, and I'm sure all of you are coming from a company who has a lot of employees, most of the problem can come, not most, but there is a problem that coming from internal people in the company. So, if you look at the topology of trader, if you remember the component diagram from before, we have the bank side, we have the HTML5 application, we have the AWS system, where we have our own security group and DMZ, which separate between development and production system, and we have a physical leg in a data center equivalent to NetVision in Israel. It's always funny to say it, but most people know NetVision in Israel, so equivalent to NetVision called Equinix. Equinix is the data center of the financial industry worldwide. They have a physical center, LD4, NY4, TK3, worldwide physical center. And we created an hybrid topology, which is based on Amazon as a service and physical presence in Equinix. Because we need low latency, because we need high throughput, we have to create this topology, and we could not only use Amazon to provide a full service to our solution. Now, if we want to look at the full-blown topology, we are now located in 5 regions. The region that you saw in the previous slide was Ireland. We have Virginia, we have Singapore, we have Tokyo, and we have Frankfurt. Not in all of those areas we have the physical presence, but we are running over, the slide is not up to date, I'm sorry for that, over 200 EC2 server, over 100 RDS, 70 cross-connect, Direct Connect, which is a solution by Amazon to allow on-premises security for such an hybrid solution. Actually, we gave a lecture last year in Amazon Summit about this feature, which is very important for security when you want to do it for enterprises. And I'm always proud to say we only do it with 2 IT people. All of that, 1 IT person, the head of IT is sitting here in the crowd. So that means 1 IT now is in the office, and all of this because of those guys who are doing everything behind the scene for us. So this is kind of a background about but we now need the other slide. Otherwise, the I am safe won't be presented, and this is what we are here for.
Bear with me while I see what's going on.
So, about the identity. So, we have the I am safe. As I said, up until 2 years ago, everyone could access our Amazon service. So, all the employees in the company. Okay, so this is I am safe video, so I'm going to speak on top of the video. So, I am safe is a product by Dom9, excellent product, which enables us to control what employee in the company can do. So we have the development team, we have the QA team, and we have a team that in any R&D organization. All of them could have access Amazon services, although it's a 2-factor authentication. Usually they have the second factor, which is the mobile. They can access Amazon service, and technically they can take down a server, they can increase the power of a server, they can shut down RDS, they can do whatever they want. Obviously, this is something which is unacceptable, especially not because people maliciously does that, because people tend to do mistakes. And we want to protect our employee from themselves and not allow them to have a mistake. Just as an example, if someone take a server down in the middle of a 10 million transaction, and the transaction suddenly goes away, and the bank now need to understand what is positioned for $10 million, and in 1 minute you can lose $50,000, you can imagine that this is something that is not neglectable, and you need to take care of that. So the I am safe, actually, what you see here in the video, allow us to control what people can do or cannot do on the Amazon interface. So, for example, if I want today to log into Amazon and take a server down, I need to take my mobile out. My mobile has to be protected either by a pattern or by a password before I log into my mobile. I have to activate DOM9 factor authentication in order to get a lease. And only after I get a lease, I can access our console in Amazon and do what I need to do over there. Obviously, this is a simple example of what can be done with I am safe. I am safe as a product can allow you much more flexibility. The administrator of DOM9, which is also controlled by a 2-factor authentication, I cannot just go into DOM 9 and log in with the user and a password. That's also protected by a factor authentication. By the way, we don't believe in password in Trader. We believe in multi-factor authentication. People tend to forget their password. People tend to use the same password over and over again. Password is important, but you cannot rely only on password. So everything is either two-factor or multi-factor authentication. And when someone leaves the company, we simply revoke his second factor. And that way we control the user, and we don't care so much about renewing password every 30 days and whatever. So I'm safe does as an implementation of what Dave was speaking about in the last 20 minutes, give you the ability to control who is doing what, and the person who is controlling that is different than the people who is doing. It's a great implementation, and I recommend if you are using Amazon in the way that you are using, you should use such a solution in order to protect your employee and what they can do.